Okay, so it's time to make our constellation shader. You might remember when I was making the star shader, I did two videos. The first one took about half an hour. That was when I was live coding the shader. It was a bit difficult to explain it and write the code at the same time. Also, especially in this shader language, it's easy to make compile errors and spell things wrong, this sort of thing. I'm figuring what I'm going to do is I'm going to have the shader pre-written, and then I'll be able to go through it line by line. I can even illustrate things. I'll be able to give a better explanation. So it's just a new thing I'm trying. Let me know what you think about it. I'd love to hear some feedback about what you'd prefer. I feel like this will be, I'll be easier able to convey what's going on. Anyway, we'll give it a go. We'll get started. So let's have a look at our constellation shader. Literally the only file I've created in this, in addition to what we already have, is this constellation.shader file. And okay, I'll just go through it line by line. First of all, we make the shader. Yep, we have two properties, line width. Now later on, we'll know exactly what this value is and why it is so small. But for now, yep, we have color as well. We're going to have the sub shader. It's going to be in the transparent queue. Of course, we're turning off Z-write, which means that if you want to draw a constellation in front of another constellation, or if you want to draw stars, a constellation behind another constellation, or stars behind the constellation, like if you wanted things to be a bit transparent, which again, this is also why we have our blending of whatever was already drawn behind the constellation. I know if I do this looks like in front to you. There's your constellation. There's something behind it here, and you're able to blend the two colors. That's what that line's doing. And now we have we're declaring our vertex, geometry, and fragment shaders, just like in the star shader. We're also going to be using our utility file, which is over here. And okay, so we've got our three very simple structures at the moment. Our vertex shader is about as boring as a vertex shader can possibly be. In fact, I believe that is literally the boringest vertex shader you could possibly have. Okay, and now for our geometry shader. This is where it gets a bit interesting. Let's have a look. Okay, so we're declaring our line width. Okay, we're saying we're giving out four vertices out, just like our billboards, except this is going to be a line, so it'll be a long rectangle. And we're passing in two. I'm wondering if I should point or highlight. I know the highlight is not very strong. We're passing in two vertices. One for for a line, you have a start and an end point of the line. Again, we're passing out the triangle stream. Okay. Now we have a look at this. What's going on here? We're finding out two forwards, and it looks like we're sort of getting the average of those two forwards. Why would we do that? Well, good question. Let's have a look at how this works. Let's say, for example, this example, I have a line. We have 2 points. 2 points, one here. Oh, and the other is off the screen. I have 2 points. Start again. I have 2 points. Make a little note of where that line ends. Okay, that's where it ends. Okay, I have 2 points, and I want to draw them. Let's say we have a camera that's down here. Okay, so this is a top-down view of this line. Well, what I'm going to need is to draw. I'm just figuring out how to do this in 3D. What I'm going to need to do is I'm going to need to draw a quad that looks kind of like this, right? It's got to be a 2D quad. It's got to have a height and a width relative to the camera. So what we need to do is we need to find out what those directions are. Well, what we certainly have to work with is we have the forward direction of this point and the forward direction of that point. Now, if we average those, we're going to have a forward direction of the 2 points, and this is really helpful. If they were off to the side, then it will be a more accurate direction, instead of saying just camera.forward. Okay, once we have the forward direction, we need to get the right direction. Well, the right direction is relatively easy because it's just the direction from one point to the other, which would be, if this is point 2, this is 0.1, it would be 2 dot position, 2 dot pos, I'm running out of room, minus 1 dot pos. Okay, so that's how we can get the direction from one to the other. So we have the right and we have the forward. Once we have those, we take what we call a cross product. In other words, it's probably better just to use my hands. If you have the forward direction, you have the forward direction. Have the forward direction. You have the right direction, like that. Anyway, you get the idea. You can get the up direction. As in, your cross product is if you have two directions, it's the one that's going that way. There we go. I use my hands. It's a bit more easy to see. So from the forward and the right, we can get the up. In other words, that's what we're doing here. So we're saying forward 1. Okay, direction forward is the average of forward 1 and forward 2. And then direction right is whatever the second one is minus the first one. And then our direction up is the cross product. And I just like to normalize it to know that we're working with absolute right and absolute up values. Okay, now let's have a look at what this screen scale is doing. This is where it gets interesting. This screen scale is like a humble little line, which is a little bit more interesting in the utility function in the utility class. But this is what makes the shader very special, and the reason is that no matter how far away the stars are, the line is, it'll render at the same width, at a consistent width. In other words, if you have a star that, okay, let's say the camera's here, you have a star here and a star here, it's going to say, I'm going to render it at a width of this much here, and because this one's so far away, and we have the, further away something is, the smaller it looks, I'm going to account for that and make it a little bit smaller. So in real life, the line looks like that, but to the camera, it looks like it's the same width. So let's have a look at how that's done. So screen scale. Get the screen scale for each of the points. Okay, get screen scale. So first of all, we're jumping into pixel scale. Well, what's that? That's saying how far away is this object, and this is where I'm going a little bit out of my realm because it's a little bit matrixy. And this, in fact, this entire function is a function that I've copied and pasted from somewhere on the internet, and I can't remember where I found it. Otherwise, I'd leave a link to it. But this is the magic. This is where it says, if it's really far away, then the meters per pixel, how big I'm going to draw it, will be much bigger. If it's really close, it'll be much smaller. So it's going to adjust accordingly. Now, the thing is that once we start deploying to, and anyway, it works in pixels. Once we start deploying to mobiles, things are going to start looking really goofy if we keep using pixels because of pixel density, different monitors. Like you do something on 4K will look completely different to something in, I don't know, on a 1080p monitor. So what we're going to do is we're going to adjust for that by saying, where instead of using pixel scale, which will vary, we're going to use screen width. So we're saying it's going to be some fraction of the screen width. If we passed in a fraction of 1, then that would be 100% of the screen width. Or, and this is like one more thing, it's going to be, instead of saying the screen width, this is the thing about cross-platform, a phone, if you rotate it, from landscape to portrait, the width suddenly becomes much smaller and everything's going to look absolutely different. So we're going to make a little hack of an adjustment there and say whatever the average is between the width and the height. So just so we have some consistent value that we can work with. All right, and then we're going to return all those adjustments. Okay, so now we have what I was describing here of some scale for this one and some scale for this one, which is relative to how far away they are. Now, what are we doing here? We're okay, so this is converting that scale, which is a float, into a direction, which is the up direction relative to the camera. Off is for offset. All right, now we're creating our geometry to fragment object, and we're converting each of those points, which are we're doing all this math in world space, and we're converting that into clip space, or object space to clip space. And this order is also important so you're saying the order in which you draw the points. In this case, it's from the second pixel's position and negative offset to the first one with the negative offset, to the second one with a positive offset, to the first one with the positive offset. That would look like, if this is your 2 points, it would look like 0, 1, 2, 3, something like that. And that is our quad. One of these will be drawn for every single line in this shader. And yeah, that's pretty much everything. Again, one of the most boring functions, fragment shaders that you've ever seen for now. There's many things we could do with it. We could make it like soft around the edges or all kinds of stuff. But for now, that's just what we're going to have. Okay, so let's see what this looks like in action. Open up Unity. I'm going to create a new material. I'm going to call it Constellation. Create a new material. Call it Constellation. Set its shader to a star chart constellation shader. That line width I'm going to make a bit smaller. You notice it's even able to render a regular sphere. That looks awesome. Okay, anyway, we have our constellation material. Now I'm just gonna. No, I will do it properly. We'll do it properly. So let's adjust our instance manager to also generate our. Oh no! Look. I'll do it in the next episode. Okay, I'll do a quick little demonstration in this one, and then I'll do it properly in the next episode. Okay. This will just be called test constellation, whatever. I'm just going to delete it after. So we need a mesh filter. We also need a mesh renderer. All right, and we're going to pass in the constellation mesh, constellation material rather, and let's see, the great boat of Tamararedi. All right, good stuff. So I'm going to get my camera and make sure my camera's looking at it. Okay, and there we have our constellation. Let's see. I'm going to make it a little bit bigger. Okay, now you notice that as it gets too big, it starts to look a little like cracked around the edges. That's all right because we're going to have stars there, and we won't really be wanting it to be that big. When there's a whole bunch of other stuff going on, you kind of want it to look a bit more subtle. We can change the alpha as well if we wanted it to be a little bit more transparent. If you wanted to render stuff behind it, etc. Okay, now next up is when we bring it all together. It's going to be great.